Today we'll be studying about acids and bases. So let's get started. Acids are non-metal compounds in water. The hydrogen ion concentration is higher. In this case, hydrogen ion can also be written as proton, since they have only one electron and one proton in the nucleus. They can be dilute or concentrated. For example, we see the word dial HCl, concentrated HCl. We see these words a lot, so they can be either dilute or concentrated. They are corrosive. However, some corrode very slowly, and they are proton donors. Again, proton meaning hydrogen ion. Then we move on to bases. So bases are oxides and hydroxides of metals. The OH minus ion concentration is higher. They are insoluble in water. However, there's a class of bases known as alkalis, which are soluble bases. They are corrosive and dissolve in water to form alkaline solution. And over here, they are proton acceptors. That means they accept the hydrogen ions. You can remember this way in the form of sets. So in acids, we have nitric acid, hydrochloric acid, phosphoric acid, and sulfuric acid. Meanwhile, in bases, we have calcium oxide, magnesium oxide, copper oxide. All of these are solid. And inside bases, we have alkali, a subclass, which is calcium hydroxide and sodium hydroxide. And remember, these both are always aqueous. Now we'll look at the pH scale. So as we go from 0 to 6, the acidity decreases. So over here, let's say that we go from over here. So these are all weak acids. And 7 is a neutral when it is neither acid nor alkali. And then from 8 to 14, the basic nature of the substance increases, with 14 being the most basic and 8 being the least basic. And over here, universal indicator color change is shown, it is not suitable for titration, however, due to a range of colors being shown. So we really don't know when we have reached the end point. Now we look at color changes and other indicators. So litmus acid, in acid it is red, in base it is blue. Thymolphthalein, this is very important for titration experiments. It is colorless in acid and blue in base. Then we have methyl orange, which is red in acid and yellow in base. And phenolphthalein is not in portion, but I've still added it for extra information. It is colorless in acid and pink in base. Now we look at typical acid-base reactions. So acid plus metal always forms salt plus hydrogen. This is very key to remember. Kindly note that down. And acid plus base is equal to salt plus water. And acid plus carbonate is equal to salt plus water plus carbon dioxide. Here are a few examples of the reactions. So first we have magnesium solid plus 2 hydrochloric acid liquid, which gives MgCl2 plus H2. For the first type of reaction, where acid plus metal gives salt plus hydrogen. And then for the second reaction, we mix a base and acid. So NaOH plus HCl gives H2O plus NaCl, which is salt plus water. Acid plus base or base plus acid is always equal to salt plus water. And then we have the reaction of carbonates and acids. So acid plus carbonate, which is over here it is carbonate, Na2CO3 is a carbonate, plus 2HNO3 gives 2NaNO3 plus CO2 plus H2O. So remember, acid plus carbonate always gives salt, water and carbon dioxide. Now we move on to titration. So like this is every titration's ionic equation, just 2H plus aqueous plus O2 minus solid, which gives H2O liquid. This is for bases. Note that the oxygen here is solid. And over here H plus aqueous plus OH minus aqueous. Note that OH minus is aqueous. Gives H2O liquid, and this is for alkali. And here is the setup of a titration. So we have a burette, very important, burette. take a lighter color to highlight that. We have burette, we have clamp stand, conical flask with solution, burette, clamp stand, conical flask with solution, and a white tile. So how a titration occurs is that you firstly put an acid or a base into the burette and let some of it trickle down until it comes to the burette scale level, and then in conical flask you put the amount of acid or base. It depends on what you have taken in the burette. If you have taken an acid in the burette, put a base in the conical flask and vice versa. Add 1 drop or 2 drops of indicator into the conical flask and place on the white tile to observe the color change better. So the moment, let's assume that we have taken thymophthalate. Let's write it down. We have taken thymophthalate. So over here, as we can see, the thymophthalate is colorless in acid and blue in base. So let's assume that we have taken a base in the conical flask, so it will be slightly blue, and the moment the blue color disappears, you know that we have reached the end point of the neutralization reaction. In both cases, hydrogen is donated protons by the acids and ions accept them to form water molecules. This is a very important statement to remember. Moving on to oxides. There are 3 types of oxides: basic, amphoteric and acidic. So basic oxides are usually metals. Amphoteric, a few examples are Al2O3, ZNO and PbO, which is lead 2 oxide. And acidic oxide are usually non-metals. So now we look at formation of basic oxides. So firstly, here we have calcium. So a piece of calcium is heated and plunged into a gas jar of oxygen. It burns into an intense white flame with a tinge of red, and the white ash, the white remnants of it, it's called calcium oxide. So here's a reaction for it. CaS plus O2 gas gives us CaO solid. And then we look at the reaction of iron. So hot iron wool is plunged into a gas jar of oxygen. It glows bright and orange and throws out a shower of sparks. A black solid is left in the glass jar. It is iron 3 oxide. So 4Fe plus 3O2 gas is 2Fe2O3 solid. Lastly, copper is too unreactive. We'll draw copper over here. Copper is too unreactive to catch fire in oxygen, but when it is heated in a stream of the gas, oxygen, its surface turns black, and that substance is called copper 2 oxide. So it will be 2CuS plus O2 gas gives 2CuO solid. And as we studied in the metals chapter, the more reactive the metal, the more vigorously it reacts. Now we look at formation of acidic oxides. So over here, powdered carbon is being heated over a Bunsen burner until red hot and then plunged into a jar of oxygen. It glows bright red and the carbon dioxide is formed. So the reaction for this experiment is carbon plus oxygen gives us CO2, carbon dioxide gas. Then we look at sulfur. It catches fire over a Bunsen burner and burns with a blue flame. In pure oxygen, it burns very bright, and the gas is sulfur dioxide. It is S. Sulfur plus oxygen gives a sulfur dioxide gas. And our final reaction. So phosphorus, it bursts into flame in air or oxygen without heating. That's why it is stored under water. And a white solid, which is called as phosphorus pentoxide, is formed. P4 plus 5 oxygen gives P4O10 solid. Thank you.